Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Okay, let's have the standard position of an angle. So the angle is measured positive if it is counterclockwise from the positive x-axis. So if the rotation is counterclockwise and this is the angle here, this angle is positive if measured counterclockwise. So that's positive angle, positive theta. And if the angle is rotated clockwise, then from the positive x-axis, then that angle is negative. So again, positive angle if it is measured from the positive x-axis counterclockwise, that's positive. Otherwise, if it is clockwise, negative. Then these are the different positions of angle. If it is in the first quadrant, then the six trigonometric functions here would be positive because x is positive, y is positive, and r. By the way, r is always positive. R is square root of x squared plus y squared. So r is always positive. So all trigonometric functions are positive. Sine theta is y over r. Cosine theta is positive x over r. Tangent theta positive y over positive x. Then cotangent theta positive x over positive y. Then secant theta is r over positive x. Cosecant theta r over positive y. So this is the angle in the second quadrant. So this is, by the way, theta is called reference angle, the acute angle between the terminal side and the x-axis. The x-axis may be positive x-axis or negative x-axis, as long as it is the positive acute angle between the terminal side of the angle and the x-axis. Always remember that. Then here in the second quadrant, x is negative, y is positive. Of course, r is always positive. If it lies in the third quadrant, like that, then this is the reference angle. So y is negative, x is negative, and that's theta. R is always positive. If it lies in the fourth quadrant, x is positive, y is negative, and r is always positive, of course. So therefore, in the first quadrant, all trigonometric functions are positive. In the second quadrant, positive are sine of theta, positive y over r, and its reciprocal, which is cosecant theta. The rest will be negative. In the third quadrant, only the tangent of the function and the cotangent of the function are positive. The rest will be negative because cosine of theta is negative x over r. Sine theta is negative y over r. So those are negatives and the reciprocals. In the fourth quadrant, only the cosine and its reciprocal, which is secant of theta, are positive. The rest will be negative. For example, sine of theta is negative y over r, so negative. Then cosecant theta r over negative y, tangent theta negative y over x over positive x, cotangent theta positive x over negative y. So those are negative, except cosine theta and secant of theta, which are all positive. So x squared plus y squared equals r squared, and tangent theta or theta is called the reference angle. Again, reference angle, the acute positive angle, the positive acute angle formed between the terminal side of the angle and the x-axis, positive or negative x-axis. So we have common proportions of a right triangle. You should familiar with this. We have the 3, 4, 5. I think you are familiar of this. All of you are familiar of that proportions because square root of 3 square plus 4 square is 5. So that's why we have 3, 4, 5. Next is 5, 12, 13. You can check square root of 5 square plus 12 square is 13. Then we have the 8, 15, 17. Square root of 8 square plus 15 square is 17. And the last is we have the 7, 24, 25. square root of 7 square plus 24 square is 25. So I hope you're familiar with that, so that you can compute or determine right away the trigonometric functions when the sides are this. Then we have trigonometric function values of any angle in terms of the reference angle. So if you're not allowed to use the calculator, for example, or for given acute angles, the values are given from tables, then you can express or you can determine the trigonometric function of an angle, specific trigonometric function of any angle in terms of the reference angle. So for example, find the value of sine 125 degrees. 125 degrees is in the second quadrant. And if it is in the second quadrant, so that's the triangle, this is 125. And the reference angle, remember, is the angle formed between the terminal side and the x-axis. So this is the x-axis, the negative x-axis, that's the terminal side. So if this is 125 degrees, the reference angle is 180 minus 125, and that is 55 degrees. And since sine of 125 is y, which is positive over r, so we conclude that sine of 125 degrees in terms of the reference angle is also positive sine of 55. So the answer, sine 125, is positive sine of 55. Remember, sine of an angle is equal to sine of its supplement and vice versa. Sine of 125 is sine of 180 degrees minus 125, which is sine of 55. And that is true. Example 2, find cosine of 256 degrees. 256 degrees is in the third quadrant because it is less than 270. So that's the triangle. This is 256 degrees. And since it exceeds 180 degrees, this is the reference angle. The reference angle is 256 degrees minus 180 degrees. That's 180. So 76 degrees. And since cosine of 256, the terminal side lies in the third quadrant, x there is negative, y is negative, and r is positive because r is always positive. Cosine of 256 is x negative x over r. And since cosine of 256 is negative, then in terms of the reference angle, cosine of 256 is negative cosine of 76. If you want to check, use your calculator there. You evaluate cosine to 256 and compare it with negative cosine 76. They are equal. If you have your calculator, check sine 125 and compare it with sine 55. So they are equal. Lastly, find the tangent of negative 559 degrees. So when the angle is negative, it means that we have to measure it clockwise. So this is more than 360 degrees times 2, 720, negative 720. So that's also less than 720. So we have one complete revolution clockwise, negative 360, then minus 90, negative 450, minus 90, negative 540. So it's now closed. So negative 540, 9 plus minus 19. So it is in the second quadrant. So it is in the second quadrant. The reference angle here is 19 degrees. How is 19 degrees obtained? 559 minus 360 minus 180. So 559 minus 540 up to here in clockwise direction. So 19 degrees is the reference angle. And since tangent of negative 559 is in the second quadrant, y is positive, x is negative. So positive y over negative x, it's negative. So tangent of negative 559 is, because tangent is negative in the second quadrant, it is negative of tangent 19. So negative tangent of negative 519 is negative tangent of 19 degrees. So that's it for uh, trigonometric function value of any angle in terms of the reference angle. Okay, let's proceed to the general equation of a line. The general equation of a line is also the general equation of a first degree curve, which is ax plus by plus c equals 0. And I hope you're familiar with that. And the slope of a line is equal to denoted by small letter m, and it is equal to the tangent of the angle that that line makes with the positive x-axis. Remember the sign convention for the angle, counterclockwise positive and clockwise negative. So the slope of the line denoted by m is equal to the tangent of the angle it makes with the positive x-axis, and it is also, from this equation here, the negative of coefficient of x divided by coefficient of y, or negative a over b. So the slope of a line is m, and m is tangent theta, and it is also negative a over b, and theta is the angle that the line makes with the positive x-axis. So it should be counterclockwise measurement. If it is negative, then the angle theta is treated also negative, and you press the tangent of that negative angle. So that's the slope. Positive slope is if the line crosses the first and the third quadrant. That is 0 degree is less than theta less than 90 degrees, and 180 degrees less than theta less than 270 degrees. If you have your calculator there, press tangent of 75 degrees, which lies in this range, and tangent of 220 degrees, which lies in this range. So if you press tangent of those angles, it will give you positive result. Negative slope, so that's positive slope. This is zero slope when theta is exactly 0 or 180 degrees. So tangent of 0 is 0, and tangent 180 is 0. So that gives you 0. So that's the 0 slope. Negative slope if it is sloping down to the right, and if it crosses the second and the fourth quadrant where tangent is negative in those quadrants. So 90 degrees less than theta less than 180 degrees, and 270 degrees less than theta less than 360 degrees. So for example, tangent of 135 is negative 1. Tangent of 315 degrees is also negative 1. So to check, the slope is negative for those mentioned angles. Then the intercept form of equation of a line, if you move positive c to the right, it becomes negative c. Then divide everything by negative c, so it becomes x over negative c over coefficient of a, or x over a, plus y over negative c over b, or y over b equals 1. So in short, the intercept form of equation of a line, this is used for sketching lines, straight lines, is x over a plus y over b equals 1, where a is negative c over a, capital A, and b is negative c over capital B. So those are the x and the y intercepts. And the maximum value of y equals sine x and cosine x is 1. Remember that. So for y equals sine x and y equals cosine x, the maximum value is 1. Then shortest distance from a point to a line. There's a formula from analytic geometry. And if you want the derivation, you might see the derivation of distance from a point to a line in YouTube, or if not, you just wait until I present analytic geometry here, and I will derive it for you. Or you can find this in standard books, the derivation of the distance from a point to a line, and it is absolute value of ax sub 1 plus by1 plus c over square root of a squared plus b squared. So from x1, y1 to a line is absolute value of ax1 plus by1 plus c over square root of a squared plus b squared. Example, find the distance from a point 1, 2 to the line 5x minus 2y minus 10 equals 0. So let's have two solutions here. Assuming you cannot remember the formula, then there's no problem. We'll just use analogum and geometry. We'll just use trigonometry and geometry here to find that distance. So let's have the formula first. So absolute value of 5, x1 is 1, minus 2 times x times y1 is 2, then minus 10 over square root of a square plus b square. So square root of 5 square plus 2 square. So that would be 1.671 units. Then what if you cannot remember the formula? So we have to use trigonometry here and geometry. So solution number 2, we have to transform the line into intercept form and locate 1 comma 2, and the line 5x minus 2y equals 10, then divide everything by 10. So the first term becomes x over 2. The second term is y over negative 5 plus y over negative 5 equals 1. So that means the x-intercept is positive 2 and the y-intercept is negative. The x-intercept is positive 2, the y-intercept is negative 5. So these are the intercepts, 2 comma 0 and 0 comma negative 5. Then connect them with a straight line and extend. That's the line, and we are looking for this distance here. This shortest distance or perpendicular distance to this line. So since we have to solve this by another method, this point here is 2 comma 0. So let's connect these two known points and we can find the distance. And let's call that distance 1. And the angles, so we drop this line. This is 2 units because that's 1 comma 2. And because this is 2 and that is 1, so this is 1 unit. So that's 2 units, that's 1 unit. So from there we can solve for this angle. Let's call this alpha, so that perpendicular distance d is d sub 1 opposite of alpha, so d sub 1 sine of alpha. Hypotenuse sine of alpha is opposite d. Then let's call this theta, the slope, the angle that the line makes with the positive x-axis. Then this angle here is, let's call that beta, so that alpha is 180 degrees minus theta minus beta. So d is d1 sine of alpha. Let's set up that equation. That's our working equation. Where d sub 1 in this right triangle here, d sub 1 can be solved by Pythagoras theorem. Square root of 1 square plus 2 square is square root of 5 units. Then tangent of beta is 2 over 1. So beta is, using your calculator there, 63.45 degrees. Then the slope of the line is negative 5 over negative 2. Tangent theta is negative 5 over negative 2, or tangent theta is negative a over b. So coefficient, negative coefficient of x, so negative 5 over coefficient of b, which is negative 2. So theta is equal to arctan of 5 halves, or 68.199 degrees. So from there, we can solve alpha. 180 degrees minus 68.199 minus 63.45. So alpha equals 48.366 degrees. So having known alpha, let's substitute it in our equation here. So d1 square root of 5 times sine of 48.366 degrees. So d is equal to 1.671 units also, just like that. So in other words, we can always solve distance from a point to a line, even if we can, even if you cannot remember this formula here, which can also be derived. Now, another way is, instead of d sub 1, you can also consider distance between this point here and 1 comma 2. Then you just compute the angle between them. Then if that is distance 2, then d is distance 2 sine of the angle here. Then of course you have to solve for this, the angle formed between that line and the x-axis. So we have solutions to non-right triangle, and there are two laws here. One is the law of sines and the other one is the law of cosines. So this is a triangle, and you can always circumscribe a triangle about any triangle. So the radius of the circle, circumscribing circle, is denoted by r, and the sides are correspondingly small letter a, small letter b, and small letter c. Then sine law is derived in my other video, in my other channel, or in my other video, and you just refer to the derivation there. So sine law, a over sine of angle A equals b over sine of angle B equals c over sine of angle C, and that ratio is constant, equal to the diameter of the circumscribing circle. So side A over sine angle A equals side B over sine of angle B equals C over side C over sine angle C equals the diameter of the circumscribing circle, or 2r. Then the law of cosines is, you just familiar with the statement, any side square is the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle between those sides. So that is a square is equal to, you just familiar one, b square plus c square minus 2bc cosine of angle A. So if we pattern, b square equals a square plus c square minus 2ac cosine of angle B. Then c square equals a square plus b square minus 2ab cosine of angle C. That's the law of cosines. Then sine theta is sine 180 degrees minus theta. I always emphasize this because you will always encounter that. Sine of any angle is equal to the sine of its supplement. Sine of 30 is 1/2. Sine of 150 is also 1/2. Then facts about a triangle. To form a triangle, the sum of any two shorter sides must always be greater than the longest side. That's the fact about a triangle. So do not just assign any side of the triangle and assume that it can form exactly a triangle when all the ends are joined. So it's not, it must satisfy this situation condition here. So example, which of the following sets of sides can form a triangle with the ends joined? So which is a right triangle? So for a triangle to form, for these sides to be sides of a triangle, then let's apply the definition there, that the sum of any two shorter sides must be longer or greater than the longest side. And a right triangle is a triangle that satisfies Pythagoras theorem. So for part A, 10 plus, these are the two shorter sides, 10 and 20. And 10 plus 20 is 30, exactly equal to 30. So therefore, it cannot form a triangle. So cannot form a triangle. For B, the shorter sides are 10.2 and 6.4. So 10.2 plus 6.4 is greater than 12. So therefore, these sets of sides can form a triangle. But let's check if it satisfies Pythagoras theorem. 10.2 square plus 6.4 square is not equal to 12 square or 144, because 145 is not equal to 144. Therefore, it is not a right triangle. For C, the shorter sides are 26 and 48.75. So 26 plus 48.75 is greater than 55.25. So that can form a triangle. Does it satisfy Pythagoras theorem? So let's check. 26 square plus 48.75 square, is that equal to 55.25 square? So using your calculator, 3052.5625 is 3052.5625. So set C satisfies Pythagoras theorem. Therefore, C is a right triangle. Then letter D, the shorter sides are 18 and 10.8. 18 plus 10.8 is less than 29. Therefore, this cannot form a triangle. So that's it for this situation. So next, let's have some formulas. So we have here a triangle of angle beta, then another right triangle superimposed to this given triangle, and for simplicity, let's call distance AD as 1 or side AD as 1 and the angle here as alpha. So first, considering this upper right triangle, the parts are this AB here is 1 hypotenuse cosine of alpha or 1 cosine alpha. The opposite is 1 sine of alpha. And therefore, in triangle ABC with hypotenuse 1 cosine alpha, the opposite is 1 cosine alpha sine beta or 1 cosine alpha sine beta. The adjacent side is hypotenuse 1 cosine alpha times cosine of beta. So this is 1 cosine alpha cosine beta. This is 1 cosine alpha sine of beta. Then we draw horizontal line from B and vertical line from D. And take note that this is also beta here. So common hypotenuse, and we have parallel lines, horizontal lines, so beta also. Then the angle between the vertical line here and this horizontal is also beta because this is 90 degrees. So this is 90 degrees minus beta. So that means the angle here is also beta, the vertical line and this side here, BD, is beta. So with this triangle here, the adjacent side is hypotenuse is 1 sine alpha, and this is beta. This is adjacent to beta, therefore this is hypotenuse 1 sine beta cosine of beta. 1 sine alpha cosine of beta. This is opposite of beta, the hypotenuse is 1 sine alpha, so therefore this is 1 sine alpha sine of beta. Then let's project downward from this corner here. And take note that this FE here is equal to this 1 cosine alpha sine beta. And this EC here is equal to FB or 1 sine alpha sine beta. So from the figure in triangle ADE, we can now define sine alpha plus beta, which is opposite DE over hypotenuse 1, where DE is DF plus FE. So sine quantity alpha plus beta is df plus fe over 1. And remember, that's still 1. df is sine alpha cosine beta, while fe is cosine alpha sine beta. So therefore, sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So that's the formula for sine alpha plus beta, sin cos plus cosine. Then cosine of alpha plus beta is AE over 1, where AE is AC minus EC, and AC is cosine alpha cosine beta, while EC is sine alpha sine beta. So cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, or simply cos cos minus sin sin. That's cosine alpha plus beta. Cosine alpha minus cosine beta minus sine alpha sine beta. Then for tangent alpha plus beta, it is sine alpha plus beta over cosine alpha plus beta. So let's copy this formula, sine alpha cosine beta plus cosine alpha sine beta over cos cos minus sin sin. We divide both the numerator and the denominator by cosine alpha cosine beta. Then we'll have, after simplification, so we can cancel here. So divide also the denominator by cosine alpha cosine beta. So we can cancel cosine beta in the first term here. Sine over cosine alpha is tangent alpha. So this is tangent alpha, cancel cosine alpha. So this is tangent beta. This is 1 minus tangent alpha, tangent beta. So therefore, tangent alpha plus beta is tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. Then let's have the double angle formulas. So all you have to do is replace alpha and beta here by theta. So sine of theta plus theta becomes sine of 2 theta equals sine theta cosine theta plus cosine theta sine theta. And these are like terms. So sine 2 theta is 2 sine theta cosine of theta. Similarly, cosine of theta plus theta is cosine theta minus sine theta sine theta. So simplifying, that's cosine 2 theta equals cosine square theta minus sine square theta. Now, if we replace cosine square theta here by 1 minus sine square theta, another formula for cosine 2 theta is 1 minus sine 2 sine square theta, because this is 1 minus sine square theta. So 1 minus sine square theta minus sine square theta is 1 minus 2 sine square theta. If instead we replace sine square theta here by quantity 1 minus cosine square theta, then it is cosine 2 theta is 2 cosine square theta minus 1. So for cosine 2 theta, there are these three identities. Then tangent of 2 theta is 2 tangent theta over 1 minus tangent square theta. You just replace alpha and beta by theta, so you get that double angle formula for tangent function. Then half angle formulas. These formulas here are derived from these three here, or from these two, sorry, these two formulas here. So sine theta over 2 is square root of 1 minus cosine 2 theta, or if you replace theta here by theta over 2, so this becomes 2 times theta over 2, or cosine theta. So sine theta is equal to square root of 1 minus cosine theta all over 2. And this is positive square root of 1 minus cosine theta over 2. That is taken from this formula here, replacing theta by theta over 2. And this is positive from 0 to 360 degrees. For all values, 0 to 360 degrees. Because even in the second quadrant, that's half of 360, 180 or below, sine function is positive. Then cosine theta over 2 is taken from this formula here. Replace theta by theta over 2. So this is cosine theta. Transpose negative 1 to the left. So cosine theta over 2 is plus minus square root of 1 plus cosine theta over 2. Why plus minus? Because in the second quadrant, 180 degrees or less, cosine is negative. So that's why you have plus minus square root of 1 minus cosine. 1 plus sine theta, sorry, 1 plus cosine theta. This is 1 plus cosine theta over 2. Then that's for 0 less than equal to theta less than equal to 180. In particular, 0 to 180 degrees, then cosine function is positive, but 180 to 360 degrees, cosine theta over 2 becomes negative. So in general, that's plus minus. Then tangent theta over 2 is simply plus minus sine over cosine. So it is plus minus square root of 1 minus cosine theta over 1 plus cosine theta. That's for tangent theta over 2. That's it. Then 0 less than theta less than 360 degrees. Then we have negative relations. Remember, positive angle is counterclockwise, like that. So clockwise angle is negative. So for negative angle, the opposite is negative y. If this is positive y, x is common in the first and fourth quadrant. X is positive. Y is positive in the first but negative in the fourth. R is always R. So from the figure, sine of negative theta is negative y over r. So it is negative sine of positive theta. Negative y over r, so negative sine of positive theta. Cosine of negative theta is x over r. So it is just cosine of positive theta. And tangent of negative theta is negative y over x, but y over x is tangent theta. So therefore, tangent of negative theta is negative y over x, or negative tangent of theta. So in other words, sine, the reciprocal cosecant, tangent, and the reciprocal cotangent are odd functions because they become the negative of the original function, while cosine of negative theta or cosine theta and secant theta are even functions because they do not change. Even if the angle is changed to negative, it remains cosine of the angle, positive angle. So that's it for negative relations.